Ladies and gentlemen, this is Joe's Classic Video Games, back with another cool pinball repair video for you this evening. We are working on this Bally $6 million man pinball machine for a customer. And on the previous video, we kind of showed the condition that it was in and worked on the power rectifier board and the transformer, which is in pretty rough shape. And we replaced a bunch of wiring, or connectors I should say, and worked on it. We replaced even the actual rectifier board and made it do its thing. And we now have the some good voltages coming out of that. That seems to be rock steady and everything's cool. But now we're going to move up here to this solenoid driver board, which appears to be working, but it's we're trying to make this solid for the guy so it'll last a while for him. And then ultimately we're going to get over here to this MPU board, which is actually a newer model replacement one, but it's not booting. So that's what we're working with today. Now on the previous video, I just noticed we had a bunch of the general illumination lights that were out. These worked over here, you see the one flickering, but this whole side didn't work, but now it is. So I don't know, maybe we fixed that whenever we worked on the connectors, but we'll get into that. So next up, we're going to take this solenoid driver board. It's working properly, it's got the right voltages and all of that, but we're going to take it out and service it a little bit, just to make it a little more reliable long term, hopefully. So I'm going to take that out with a screwdriver, we'll put it on the bench and check it out. I'm trying to work on this board, and all Matt wants to do is talk about Michael Jordan. So here's our board. I have a paintbrush, because I'm going to take off the dust. It's like magic. Matt, somebody in one of the videos today said you seemed like a cool guy. I informed them that you are not a cool guy.
I was about to say, I feel sorry for them.
All right, folks, so we're going to clean off the dust a little bit. You know, I've been doing this more than I used to, Matt. I like being able to see everything and see if it looks all screwed up. Actually, now, I don't go over the line, you know. I don't go crazy with it.
You like to be able to actually read the labels?
Yeah, you know. Okay, folks, so I've done about 30 videos on these solenoid driver boards, okay? So you should already know how to do them, but you might be a new person, and if you are, boy, did you come to the right video. So here's the deal. Matt, what is this?
Well, it sounds like a solenoid driver board.
Solenoid driver board. This board, the bottom half of it, controls all of the solenoids in the game. So the computer, the MPU, sends a signal through this connector to this decoder chip, to these little chips that turn on one of these transistors.
Right.
The transistors, on the other end of the transistor, through the wiring, on the other end of the transistor there is a coil, and the coil always has power to it. Whenever the computer uses these chips to ground this transistor, it sends ground through the, you know, it connects ground to the
right.
coil, which makes the coil pull in.
That's called low side switching.
See, we're trying to keep this for the beginners, Matt. You're not supposed to go, oh, I'm an engineer, I know all about that, I learned that in school.
Makes it easy when you're searching terms on the internet.
Low side switching. So it switches things on the low side instead of switching the power.
Right.
Okay. And now somebody was asking me, why don't they just hook up the CPU directly to the transistors?
It would probably work once.
Yeah, it would work, but once this sinks to ground, you're basically running the voltage that's at the coil to it, which is like 43 volts.
Well, the other thing too is those transistors. Those are transistors, right? Not MOSFETs, I assume.
Good question. They're
right.
tip 102s.
All right, that sounds like transistors. So yeah, those things require a lot of current to drive.
Yeah,
and your CPU can maybe drive like 60 milliamps.
So if you get a coil that screws up on the playfield, it also will screw up the associated transistor on this board.
Yep.
So if this board has been in another game, and let's say that the one of the coils burn up, so maybe it's the left pop bumper. That doesn't always blow the fuse. Sometimes it will. Sometimes it will just burn up the transistor and burn up the coil, and then there's a dead short there, but the game will still play. I don't know how. You'd think that it would blow the fuse. Maybe it does blow the fuse. I don't know. But
well, it could be running at the right current, but those transistors just aren't rated for continuous use.
Yeah, it could be.
They're probably only rated for like 10% on, 20% on.
Yeah. So you got to go through and check all of these to make sure all your coils are going to work. So that's the bottom half of the board. This part of the board is a 5-volt voltage regulator. So it has 12 volts that comes in. It's really like 13 or 14 usually. And it
The technical term is 12-ish.
12-ish, yeah. This transistor, this bottle cap transistor on this big heatsink turns it into 5. Okay? And this is a filter cap for it to get all of the waves out of it. And then this area here is the high voltage for the displays. So it takes like 250 volts DC, something like that, and there is a little potentiometer in here where you can adjust it, and you can set it between 170 and 190, something like that. I think in the manual it says to do 180, but a lot of people run it at like 170. It makes the displays just slightly dimmer. You can't even hardly tell, but it makes them last longer just because you're not juicing them so much. They're plasma displays. So, Matt, what game does this go in?
Well, it sounds like it goes into pretty much any Bally game.
Yep. So if you have a Bally from 77 to about 83, basically any of the old Bally's, this will fit in it. They're all the same. They look a little different. Sometimes they're set up just a little bit different, but they'll all work. Okay, and they will also work in all of the Stern games. So if you're watching this video, you don't have to have a Bally $6 Million Man. What other games could they have, Matt? Let's see if Matt knows any other Bally pinball machines.
See, I know pinball machines, but I don't necessarily keep up with the brand. Knight Rider, is that a Bally?
Yes, but no, but oh yeah, there is a solid state version. Yeah, so if you had a Bally Knight Rider, this board will go in it. What other ones, Matt?
Well, you said Stern, so I guess the Stern Star Wars? The old one?
No.
No? All right, too old?
Yeah, no, too new.
No, the old one.
That's not Stern, that's Daddy East. Now they know we've got a Daddy East Star Wars that we're going to make. Okay.
You can cut that.
Oh, man, I might have to cut that out. Okay, so if you've got it like a Bally Matahari, this will go in it. If you've got a Bally Kiss pinball machine, this goes in it. If you've got a Bally, we're putting in a $6 Million Man. If you've got a Supersonic, this will go in it. If you've got a Evil Knievel, this will go in it. If you've got a Bally 8-ball, this will go in it. Any of those early Bally's, this is the one. So if you've got a machine that's Bally, everything we're doing to this $6 Million Man, you can do the exact same thing to your machine. It will literally be exact inside. Even the wires go to the same place. And the reason I did that was because that's a smart way to design it. They just changed the art and how it looks. And, you know, as the customer, you never see any of this stuff, so you don't care if, like, Matahari and Kiss have the same solenoid board. You never even know. And it wouldn't hurt the gameplay anyway. So, my whole point is, yes, this is for a $6 Million Man, but and we've done about 10 of them on 10 different games. Any of those, the same thing applies. It works the exact same. They've been giving me hell, Matt, about the star ground wiring. A star ground, do you know? I don't understand that.
Yeah, I know in audio circuits that's generally a good idea, but what?
So basically, they send the grounds up on some wires, and we have problems where the games will reset and stuff because they end up getting resistance in the wires or the connectors or whatever. So one of the mods that people do on these solenoid driver boards is they tie all the grounds together. So like this ground for the voltage regulator doesn't connect to this ground.
Right, that's a safety thing.
You think so?
Well, that way if the hot from your 43 volts goes to your 5 volts, it won't conduct because the grounds are separate. And when I say safety, I mean the machine's safety. It's safe for you either way.
I'm trying to think if that's right or not. So, okay. So there's no 43 on this, though. So, but let's use this for example.
Well,
so this is 250 volts. This is 5 volts.
Okay, the high voltage. I thought that you said that was
Oh, okay.
43. The high voltage.
So 250 volts over here
right.
needs to have a separate ground
Right.
from this one here.
It's a good idea for a safety standpoint. That way.
But they go off the board and they connect the ground off the board.
Also, they all go back to the same ground?
Yeah. They just have different long-ass wires that go to this one and to this one.
Oh, yeah, then it doesn't matter.
Well, they're telling me it does. They said exactly what you said.
See, What I'm
so
saying,
they're as uninformed as you are. Is what no, is it a safety thing? I don't think it matters.
well, I'm thinking of like,
I think actually I'm improving the safety.
is it going through a transformer? Because that's the only time it would matter.
It's coming from a transformer.
And is the transformer grounded on the secondary side or the primary side?
The secondary side.
Then yeah, if it's grounded on the secondary side, that doesn't matter.
Yeah, see, so the whole thing is the ground from this runs through a wire on one little pin over here, all the way back over to the transformer. And then there's a separate ground from this that runs through a separate pin all the way back to the transformer, and they're attached at the same place on the transformer. So one thing that we do is we tie this ground to this ground to this ground, so that everything's grounded to a plane instead of grounded back to like one little point through one little connector. That's the theory behind it, at least. Because the problem that you run into is sometimes if you've got, because they're separate boards, right?
Right.
So you run into a problem where if the ground on this board is 0.2, it's not really at the same level. You know what I mean?
Right. So you'll get backflows and all kinds.
You get
nonsense.
crap where like coils lock on and stuff like that.
Right. If the ground's not the same level, you have current going directions you don't want it to go.
Yeah, it's a real problem in the Gottlieb games. But see, they give me crap because I say Gottlieb too. They say it's Gottlieb.
Yeah, but
so really, it's just people giving me crap, is what it is. Yeah.
Well, that's a German name, right?
I don't know. I don't know the guy.
I was assuming it's a German.
I don't know him.
We don't bother pronouncing German things, right?
That's a good point. Yeah, we get a lot of German people watching. Matt, you're insulting the Germans.
I mean, we
love the Germans. Matt might not, but he's a jerk.
Look, we say Volkswagen, all right? Not that Volkswagen nonsense.
That's true, too. That's true. Okay, people, we'll get off of that. All right, so we're going to do a few little mods to this because I like tying the grounds together. Other people may not, but I do. And it's worked pretty well for me. I had a guy giving me hell about it, and he said, basically what you said, that is an audio, it's a thing that they do in audio circuits, not sure how important it is in pinball machines. And I was like, if there was only somebody that's done hundreds of them that we could ask, that could tell you what you should do in a pinball machine. But they don't consider me an expert. I'm not saying I know but more than anybody else. I'm just saying I've done it and it works. Works good.
Yep.
That's all I know.
And the only reason I even know anything about the audio stuff is because I hear that's what you do when you're trying to get the hum out, when you've got like a bad hum.
Yeah, like that record player you tried to hawk off on me. I'll tell you about that after he leaves.
Yeah.
All right, so first thing I'm going to do is I'm going to clean it up a little bit, and then we're going to replace this filter cap because it's got to go. Okay, folks, so that's the first thing we do. We replace the filter capacitor. That's what you want to do on yours. So it is, this original one, at least on this one, is an 11,000 UF capacitor, 20 volts DC.
I think you mean
Hey! No comments from the peanut gallery. So I replaced it with a 15,000 UF, 25 volt. Now, 15,000 instead of 11,000, Matt. Is that going to work? Filter capacitor?
Let's see. Probably, because that's probably a 25% tolerance on that anyway.
Mm-hmm.
And I don't feel like doing the math, but that's pretty close.
It'd be 13.5. So 25%.
Right.
13.6, eh?
Yeah, but that one might be 25% higher. That one might be 25% lower. It's close enough, so I'm saying. Their tolerances are
Matt's
terrible.
full of crap. It's a filter cap, Matt. You can go up a little bit if it's a full filter circuit. Come on now, you know that.
I'm saying electrolytics have crap tolerance, so it doesn't. You can throw just about anything in there and it'll work.
All right, folks. So anything from 11,000 to about 15,000 is just fine. On some of these, from what I understand, I may be wrong, but from what I understand, on some of the games that had like 4 flippers or something, they went with a higher one anyway. So it became a problem years later on games like I don't completely know the circuit, but on games like the Twilight Zone, it had all kinds of crap on it. It had like 4 flippers and magnets and all kinds of stuff because it was awesome. One of the coolest games ever.
That was the one that had the ceramic ball, didn't it?
Yeah. And so it just was loaded, right? But it had this thing where if you hit both flippers at the same time, sometimes it would make the game reset because the power supply just couldn't handle it once it got weak, right?
No bueno, yeah.
Yeah, so that's a thing. So you can go 11,000 to 15,000 on that cap, and you'll be just fine. Now, I may not know why, but I've done it on like a bunch of them, and it's just fine. So go ahead, folks. So if you try to buy one of these, sometimes you'll find that these are really expensive. So like an 11,000, 20 volt, you'll be, oh man, they want $35 for that cap, but then they've got a 12,000, 20 volt, and it's only $8 or something, you know. So you can fudge that one a little bit.
And you can go up on the voltage a little bit too. If you find a 25 volt, that's fine.
Yeah, you can go up on the voltage too, so it's no problem. It's no problema. So that's the first thing you want to do. Now, the next thing you want to do is go on the back, and we're going to resolder all of the connectors around the edge because they get bad solder joints. They gave me hell about, I talked to you about that before. They gave me hell about saying solder.
Yeah.
God, what the...
Yeah, S-O-D-D-E-R.
Solder, exactly. They probably use a different product wherever they're at, and it's pronounced solder. Okay, so sometimes on these pins, especially the ones on the end, you'll get broken solder joints. Now, I don't see any at the moment, because these have been resoldered. Here, this will give you a good example. Okay, see these last 2 pins here? See the shiny stuff around them? That's flux, because someone has resoldered them before. Now, see these ones in the middle, how they're not like that? That's the original solder. And then down here at the end, it's shiny again because they've resoldered that. Now, why did somebody resolder just the end ones? It's because they probably had bad solder.
They probably, yeah.
And the reason for that is whenever you pull off the connector, so let's say you've got this connector on there, you pull it off. Well, you never pull it straight up. You're always pulling it to one side if you're left-handed, or maybe this side if you're right-handed. And what happens is when you get the plug up, the last pin, or the last couple of them, get bent a little bit. And so they just get banged around, and it literally will break it loose from the board. Sometimes if you look at it, you'll see that they're curved. See how the last pin is curved? That one? It's just bent because of how it was pulled off. I may have just done it, or somebody else may have done it. See how the end ones are messed up? So it's just a thing. So the ones on the end are always the worst, but I always just resolder all of them. But I would say I've never seen bad solder joint like right in the middle of the connector. It's always, sometimes it'll be 2 or 3 of them on the end, but...
And it's always the high current stuff too.
Yeah. Sometimes that will do it on its own, probably without even removing the connector.
It sounds fake, but high current connections will lose solder over time.
Yeah, it like transplants it somehow. I think I heard about that.
Yep, it sounds fake, but it'll do it.
That's why I believe in divining rods. What do they call that? Whenever you go with the rods to find where the water is in the ground?
That's divining rods. You have to
go ahead, Matt.
You're gonna have to make some connections here. I'm not following.
Go ahead, Matt. You said that that solder disappears from the joint and moves down the wire, and you said it sounds fake, and they can't prove it, but it happens.
Oh, no, I didn't say they couldn't prove it. I said it sounds fake.
Well, you meant though that they couldn't prove it.
No, there's
now talk about divining rods.
There's papers out there. You can go look them up.
Talk about divining rods. You don't believe in it, do you?
No.
You're a fool, Matt. You're a fool. I've seen people do it. You go out with the rods, and you hold them like this, and when they cross, there's water there. They've done tests, man. Have you never seen that?
No.
Go on YouTube. They've done tests. It works. It doesn't always work, but on average, it works.
I'll take your word for it.
It's the truth. Everybody knows. Put down in the comments that Matt doesn't know what he's talking about, and that divining rods is a true witchcraft that works.
Well, the solder transmigration, you can look at papers for the scientific papers.
Well, I could write a paper about divining rods.
You get it in scientific journal?
They call it witching.
Okay.
Witching water.
You say so, buddy.
Everybody knows you can witch water. Okay, so I'm going to resolder all these, especially the ones on the corners. And then that's the next step you want to do on yours. Okay, so that's how you want them to look. So Matt's still talking about this witching water thing. He said that Mythbusters did it. And now tell them what you said. Now, how did they do it?
So they had pipes under
Plywood. And they
some pipes had water, some pipes didn't.
And they tried to witch it with the sticks, and they couldn't do it. And then they got an expert to come in, and could the expert do it?
I said not reliable.
Not reliably, but he could do it. Right? Everybody knows witching water ain't completely reliable. I'm just saying that it does work. Okay? So he did find the water. It just wasn't reliable.
Right.
And you're complaining that whenever they tried it, what happened when the Mythbusters guys tried it?
That's why when they tried it first, they tried to do it just based off their impression from movies and whatnot, and they couldn't do it.
They couldn't do it, but the expert did it.
And then the expert tried to tutor them how to do it, but
they
still never could do it.
That's because they don't have the shine.
Sure.
All right. So he tried to teach them, and they weren't able to do it.
Right.
But he was able to do it.
Not reliably.
Wait, Matt, this is a yes or no question. Was he able to find the water with pieces of stick or bars that he held in his hand and witch the water?
Sometimes.
Okay, there we go, people. There we go. All right, so we've resoldered all that after I'm about to finish it up. I was laughing at Matt so hard. So that's the next thing you want to do. Now, here's a couple of the mods that we do that people were telling us you shouldn't do. We're going to tie the ground on this cap, which is in the high voltage area. This little here, right, the ground of that cap to the ground of the 5 volt, which is this trace that goes all the way around the edge of the board. All right. So, and if you notice here, the screws that hold the board in place actually hold that ground to the ground plane. There's a big piece of metal on the back box. It's foil, actually. So we're going to connect that to this trace. The way I'm going to do that is I'm going to scratch a little of the coating off of this trace and then put a little jumper wire. So that's the first little ground upgrade we're going to do. What this will do is this ground is on this little trace. That's the only thing it connects to. And it goes back. Well, no, it connects there too. Oh, that's a resistor on the high voltage. It goes all the way back to this one little pin, and then out a wire all the way back to the transformer and connects to the rectifier board where it's connected to all the other grounds. So we're just, if that ground gets screwed up, you get ripples in your displays and stuff. We're just going to connect the ground from here to here, which will mean that instead of the ground only having that path back to the the transformer, now it's also connecting through the ground plane where everything in the entire back box is grounded to the rectifier board. Do you think that's solid science there, Matt? Is that going to burn something up?
I'm not saying it's a great idea, but that's what they did, so might as well leave it that way.
I went and showed Matt how all the grounds are connected at the transformer. He didn't think that it should be like that, but that's how they designed it.
Like I said, if that's how they designed it, I'd leave it that way.
Now, what would happen if the ground on the displays through that one little pin was to get screwed up where it's got 10 ohms of resistance on the connector?
It depends, but the short answer is it wouldn't work.
Okay. So if I tie that ground to there, it makes it more reliable, right?
Yep.
Well, there we go. That's all I'm trying to do. I'm just trying to make it more reliable. I didn't come up with this, by the way. This is all from Clay. Everybody, if you want to get mad at somebody, get mad at Clay. He came up with it. I just started doing it because he does it at penrepair.com, and it's worked great on all kinds of machines, so it's awesome. It's the way to go, folks. Okay, so we're going to put this little jumper from here to this ground trace. Let me show you what that looks like. So there's my little jumper, people. Simple as that. Now, one of the other ones you do, this is the ground trace for the 5-volt filter cap. Same problem. It runs through one little pin, so if you get resistance on that pin, it gives you trouble. So you just tie it to the board, there's a ground trace that runs right here under it, right? See how yeah, so you got a ground running down, running to everything, blah, 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 running over here, running to all of this, okay? So we're tying that together by just putting a little jumper. That's all you got to do. Easy peasy. Okay, and you can tell the ground on the front because the other one's marked positive. Okay, so there's one other one that we do that's kind of minor. We're basically, there is a 5 volts that the board makes here, and then it sends off the board through a little jumper wire, and then back onto the board across the jumper wire that sends 5 volts to power these 4 chips. So without that 5 volt, these 4 chips can't work, right? And so there's a little jumper you can put on the back so that it doesn't have to send it out of the connector and then back into the connector. You may have some resistance on the connectors. You just jump across the board. So you're like adding a trace basically on the board that they didn't add, right? And so the way that you do that is you tie test point 1 and test point 3 together. So we're just going to put a little jumper between those 2 test points. And so here is test point 1. It's the 5 volts going off the board, right? And then test point 3 is here. It's the 5 volts coming back on the board. And if you notice, it's the last pin on the connector. So it's the one that gets screwed up with bad solder, which is one of the reasons that you want that little jumper. It just makes a better connection. Simple things. You don't have to do any of these. This is just how we do it. People always ask us how we do it. This is how we do it. Okay, so I'm going to put a jumper between test point 1 and test point 3 so that the 5 volts doesn't have to go off the board and then back onto the board to get to these chips. It just jumps right to these chips. Okay, there's our little jumper wire. Make sure you don't put it on the wrong one, people. Next thing that I did, this is the potentiometer to set the voltage on the high voltage here. I replaced it, and the reason I replaced it is because these ones are known for going bad. And so what usually will happen is you just won't have any displays because this will be open, right? So these little thumb wheel pots just get a bunch of carbon and dirt and stuff in it, and they stop working. So I put a new one. I wish you could still get this type. I can't ever find this type, so I always have to use these little cheapo things, but whatever. This one you can adjust with your hand. That one you have to use a little screwdriver, which I guess is best anyway. Okay, so swap that. And then I tested all of the transistors, the voltage regulator, and the this one here, and these. And everything was cool. So, you know, basically like you test a transistor with your diode check. You want to go through and just check all of them while you have the board out. See if you find anything shorted. Okay, so everything checked out good. So we're pretty much to the point where we're going to put it back in the game. Haven't found any real problems on it. Like I said, it was already working. Everything was cool. You can replace this cap too, which is the filter capacitor for the displays. If you do get a lot of rippling in your displays, it could be that or the ground. Everything seems pretty cool. The fuse was not blown. You saw the displays appeared to have the high voltage anyway on the previous video, I guess. I cleaned the connector pins. So you literally can use like light sandpaper or a little file or whatever you want to clean these. Some people don't like doing that. They'd rather use a chemical. You can use that too if you know of a chemical that'll clean them up better than a sandpaper or a file. I think people buy a lot of deoxit to do that. But we're pretty much ready to put it back in. We'll adjust our voltage for the displays, and we'll see how close to 5 volts we are. On the previous video, on the previous machine, or one of the previous machines, whenever we were working on that Flight 2000, we figured out that these two resistors over here, which are R50 and R49, are used with the. This is usually an LM323. They are used because that's an adjustable voltage regulator to adjust the 5 volts out. Those two resistors are basically raising that a little bit, so that instead of outputting 5 volts, it's outputting like 5.2 or something like that. But then once we have higher line voltage feeding it in, it seems like, so the 12 not being 12, being more like 14, you end up with your 5 is too high. It'll be like 5.4, 5.5. So we figured out that you can cut one of those resistors out, one or the other. I'd have to look on the schematics again. And it will lower that voltage back down. On a lot of these, they have had the LM323 replaced at some point. So this one is a 78H05. So it's 7805, but it's the H variety, which is the 5 amp version. The LM323 is 3 amp. A regular 7805, though, is only 1 amp. So it doesn't look like it's ever been replaced, though, but it may have been in antiquity. Is that solder from 1980 or from 1982? Who knows? Okay. But that's been replaced at some point. So it doesn't really cost a lot of money to service one of these. You definitely want to replace the filter capacitor. You probably want to replace that potentiometer, right? But you see, I didn't replace anything else because it's all still working. It's a pretty decent design, so no big deal. All right, so we're going to pop it back in the machine and see how close to 5 our 5 volts is, and then see if we can adjust our high voltage to 180 or so. Okay, folks, so here is the schematic. And this is for specifically $6 million man. Now, I don't know if that board actually was originally in this or if it's been switched out, but here is what that 5-volt voltage regulator is listed as. National LM323 or Fairchild 78H05. So someone was telling me, and they may be correct, I don't know, they were saying that the 323 is an adjustable regulator, 5-volt regulator, and you adjust it with the 2 resistors I'll show you here in a minute. But the 7805 is not. It's just it doesn't need the resistors, okay? So let me show you the schematic, but I'm just showing you this to show that from the factory they were putting those 78H05s in it. So the theory we were thinking was that it was supposed to be a 323, but that somebody had replaced it with the 78H05 at some point, but didn't update the resistors, and that was the whole problem. Because the voltage the output's too high on the solenoid board. So let me show you the schematic. Okay, folks, so here is the schematic. We were supposed to be getting 11.9 volts in, right? And there's the ground that we were talking about, okay? And then it runs through an 11.7 cap, okay? Now, I changed that to 15. The one that was in it was 11. I wonder if would that raise the output?
15 to 11.
No, 11 to 15,000 UF microfarad. That wouldn't really change the...
That's on the input side.
Yeah, it's on the input side. Okay, so they run it into this voltage regulator that is either a 323 or a 7805. Okay, 12 volts going in. But look, they don't have it tied to ground. They have a resistor there, 2.2 ohm resistor. They have a 4.7 ohm resistor if it's on a stern one. The stern ones have ripped off this same design. And then they have this resistor here, this R49, tying the output to the, I guess that's the base.
And that one...
And that basically raises the output. It's not 5, it's at 5.4, but they've done it on purpose. But the whole problem is, it looks like originally, since you're getting 11.9 in, that little thing would raise it up to like 5.2 so that they could tolerate like some voltage drop in the wires. But the problem is, we're getting like 14 in. I don't know that would necessarily be a problem, but since they have this, now we're up to like 5.4, which is way over tolerance on the chips, you know.
And that thing must be burning a lot of heat for that to be a half-watt resistor there.
Yeah. So here's how we fixed it on the last one. We just removed that resistor. We took R49 out. You just cut it out, and it drops your 5.4 about 0.2, 200 millivolts. So it'll drop that sucker to about 5.2 if you cut out R49. And you kind of need to do it because it's 5.4 right now. You shouldn't be running the board. You shouldn't be running chips at 5.4. I mean, that's starting to get out of line.
Yeah.
And people were suggesting that you could also do it by jumping over this R50. Just jumping that straight to ground.
Yeah, if it's 7805, you normally would put it right to ground.
Yeah. So it's just weird. So people have pointed out that for a 323, that would be a good idea. But as you just saw on the schematics, from the factory they're putting 7805s in there where you're supposed to put it straight to ground, but it's not made like that. So I'm going to clip out R49, but let me show you what it's doing in the cabinet. Okay, so first we're going to check the voltage for the displays. So that you got to be careful when you do this. That's why that plastic sheet is on there. They don't want you getting shocked because it's got about 250 volts running through it. Let me paw at it. So one of the test points will give you the input voltage. Good God, I got the shakes tonight. I'm going to get killed. Man, if I get killed, call the police. 255 coming in.
I'll make sure to record it.
179 going out. That's about where I want it. So we're good with that, okay? All right. And so now we're going to check the 5. So we've got... Boop, boop, boop. Oh, hell. I'm trying to be careful. 15.2 coming in. So it's supposed to be 11.9. We're up to 15.2, but that's pretty common. Like it's just what it does because you've got a higher line voltage, and you would think that the transformer, a higher line voltage transformer would have a higher output, but then they're rectifying it on the board, and it's still high as hell. 15.2.
That's unregulated.
Yeah, it's unregulated. So, but it's you saw in the schematics it's supposed to be 11.9. So it's 15.2. I don't know. I don't know if that has anything to do with this, but you've got 5.39 going out. That's just too high, man. It doesn't need to be that high. So 5.39 going out. I'm going to just remove that one resistor, and then we'll recheck it and see if that drops it. Okay, so I simply cut out R49, completely removed it. Okay. And now we got our 15.4 coming in, and going out we have 5.09. Perfect. It's exactly where you want it. So it's 5 and a little high for if there's any loss in the wires or the connectors or whatever, but now you're not sending crazy voltage to the thing. So I've been doing that on the last couple machines because I saw somebody talking about it on Pinside. I never realized that the output was that high, but that's crazy. Crazy, man. So you might want to do that on your machine if the 5 is really high. What do you think?
Close to 5 is good. Yep.
Close to 5 is good, but a little higher than 5. But that's ridiculous.
Yeah.
So I don't know why they did that. It would be interesting to see if you actually had 11.9 going in. Is it a thing? Well, it's rectified though. You wouldn't think that it would do that. Is it a thing that transformers the voltage creeps up over time? The output voltage?
No, not that I've usually come across.
Maybe they were never 11.9.
I mean, I know some of those metal case transistors, sometimes they'll slowly leak up over time. That's what kills the Commodores. So like that 5 volt regulator might one day in its life become a 7 volt regulator.
Okay, well maybe that's it.
But that's on the output, not the input.
Yeah. I don't know. All right, so that's how you fix that, though. Okay, so I'm going to turn it back off. We'll plug in this board just so I can show you the what the MPU is doing. That's going to be what we tackle next. But I think our rectifier board and our solenoid driver board are good to go now. Okay, so if you plug in the board, the lights are just locked on. So it's not booting, and that will be our next thing that we work with. Now, Matt looked up the data sheet on a 7805, and that 78H05 in that package.
I looked up the Fairchild data sheet for that vintage.
Yeah. And you can run 40 freaking volts into it, and it will still make it 5-volt output.
That's right.
So it shouldn't really matter what's coming in, even though it's way high. So I don't know. It's strange. Maybe at the time they wanted 5.4 volts going to it. I don't know.
I couldn't tell you.
I don't know. And then he was mentioning the we think the 15 is high, but see, I don't know. Whatever. Now the way that they do it down here is with a bridge rectifier.
Right. Well,
So if you got a high voltage going into a bridge, if it's too high going in, it would come out too high.
yeah, the bridge doesn't do anything other than just change the polarity.
Yeah.
It doesn't affect it at all.
Yeah, so that would explain why it's too high. And then Matt was mentioning, like I thought too, the voltage coming out of the wall is like a lot higher than it used to be. And here in our shop, it's high as hell.
Yeah, it used to be 110, 115. Now it's like 120, 125.
So, whatever. Okay, so got our voltages looking good. We're on to the MPU. We'll do that on the next video. Matt, tell them what to do. See if Matt knows what to do.
Wow. I mean, yeah, you always subscribe, of course.
Yeah, always subscribe, of course. Yep.
Unless you already were.
Unless you already were, and then don't hit subscribe, damn it, it'll unsubscribe you.
All right.
Don't do it, people.
Only if the button's red.
Only if the button's red, yeah. Or, no, they might change that, Matt.
Okay.
If you're subscribed, don't mess with the subscribe button.
I mean, you always like it.
You like the video, leave your comments down below,
Yeah.
especially if they're positive. I don't like negative comments. Everybody knows that. I'm very negative about negative comments.
Leave the negative comments. They're entertaining.
Don't do it. Okay, and make sure to check out my brother Donnie. You didn't tell him about that.
Oh, yes. Yes, Brother Donnie down in Jefferson with his old buildings.
Yep. Matt's been down there, visited my brother Donnie. They got in an argument.
He's as crazy as he says.
Yep. You were supposed to buy something from him, and you didn't buy it.
Oh, yeah, that railroad cart.
No, there was something like trash laying there or something. There was a roll of plastic or something, and Matt was like, what are you going to do with that plastic? Donnie was like, I'll take $20. You want it? You going to get it? And Matt was like, well, I might. So check out my brother Donnie here on YouTube. He's literally my brother. If you like watching us work on these old pinball machines, you probably enjoy watching us work on old buildings. We have a couple old buildings in beautiful downtown Jefferson. It's coming a long way, Matt. I know Matt's always down on Jefferson because he's had family down there for a long time, so he remembers whenever it was like there was no industry in Jefferson, but there are 2 or 3 stores open now, Matt.
So a 200% increase.
Exactly. So Matt's always talking. Well, he doesn't say nothing negative about Jefferson, but he doesn't see the vision like I see it. But if you enjoy watching us work on these, you'd probably enjoy watching his channel. He's pretty crazy. So we appreciate that. Make sure to leave your comments below. Give us a thumbs up. And check out our parts page, too. Go to lionsarcade.com. We have a page at the top of our website now, a parts page. Matt's been on there buying all of our parts.
I bought your solder sucker.
Yep, bought our solder sucker. Now it's not used vintage parts. It's just little stuff that we use in our repairs. So we've got like a solder sucker. I think there's a Fluke multimeter on there.
Little side cutters like you got there.
Yeah, little stuff like that. We just got links to stuff like that. It takes a lot of that stuff. Oh, our T-shirts are on there. You bought a T-shirt.
Oh yeah.
Yeah. So our T-shirts are on there. But some of that stuff, it takes you to Amazon. And if you go to Amazon and buy anything, after you click that link, it gives us a tip for sending you to Amazon. So you can buy a car. Or what did you buy on there?
Well, I bought the solder sucker and I bought some extra solder.
Oh, okay. Yeah. So anything you buy on there, it gives us a tip. So we appreciate that. But I hope you enjoyed the video. We're just having fun, hanging out, working on this solenoid board. It's a little bit farther. Next time we'll work on the MPU, and that will fix it and get it back up and running.
There you go.
That's how that works, man.
Yeah.
That will fix it. It's not going to run with the MPU with the lights locked on. It's supposed to they come on and blink.
Right.
See how they're stuck on?
Yeah. That Yeah, that's stuck.
There's a problem.
That means no worky.
We're going to have to fix it. So stay tuned. Next video up, we will fix the MPU, and that will fix the game. I promise. We'll see you on the next video.